Okay, so this video is going to be looking at the process of rusting and sacrificial protection, which can be used to protect the metal. So when iron rusts, what is happening is that the iron metal is being oxidized by a mixture of oxygen and water. So the iron, when it's oxidized, will turn into iron 3 plus ions, and in the process it will lose electrons. Now those electrons need to go somewhere, and that's where the oxygen and the water comes in. So if you have water in contact with a metal and there's oxygen dissolved in the water, or it's exposed to the air as well, you have oxygen molecules, either as a gas or dissolved in the water. You have water molecules, and they will accept electrons and turn into hydroxide ions. So the oxygen in this case is being reduced. It's gaining electrons. And those electrons are coming from the iron. So the iron is losing its electrons to the oxygen. So that's what would normally happen if you have a piece of iron it's exposed to oxygen and water. Now, there are various ways you can protect the iron. For example, by painting it or coating it in another metal, or covering it in grease or something like that to keep the oxygen and the water off. However, some uses of iron, for example, ships and oil rigs where you have large pieces of iron which are exposed to seawater, it's very difficult to actually protect that fully, to cover it fully, and the smallest scratch and it's going to start rusting at that point. So instead, we can use a method called sacrificial protection. So what happens here is you have your piece of iron, like the hull of the ship, for example, and you bolt a lump of reactive metal, for example zinc, to the surface of the iron. What's important is that it's in electrical contact, so it's a piece of metal attached to another piece of metal with a metal bolt, and so there's an electrical contact between the main body of iron and the sacrificial metal. Now, the sacrificial metal must be more reactive than the iron, so zinc is commonly used, magnesium could also be used, although it will disappear very, very quickly. And what now happens is that since the zinc is more reactive than the iron, it is going to be preferentially oxidized rather than the iron. So the zinc will be oxidized to zinc 2 plus, losing 2 electrons in the process. And obviously these electrons will be used to reduce the oxygen. So we'll have the same reaction we have before with our oxygen molecules and water reacting with electrons to form hydroxide ions. So these electrons can come direct from the zinc. But since the metal is in electrical contact, those electrons can also travel through the metal, and therefore any oxygen that's in contact with the iron at any point, which wants to be reduced, is going to be using electrons which have actually come from the zinc, not from the iron. So the iron itself will not be oxidized until all of the zinc has already been oxidized, until it's all disappeared. So as long as you keep replacing the lumps of zinc on the surface of the ship, you don't need to coat the entire surface with zinc. You don't need to galvanize the entire ship. And the reason why this works is that the seawater acts as an electrolyte. And since there's electrical conductivity happening all across the entire surface, everything is in touch, everything's in contact, and therefore the piece of zinc at any point will form a cell where the iron is going to remain unoxidized, and the reduction can happen at any point on the surface and not just where the zinc is. And so you can protect the entire hull of the ship without needing to cover the entire thing with zinc. And it's much easier just to replace little lumps of zinc rather than the entire ship.